Welcome everybody. It is April 10th, so we're in calculus right now. And so today we're going to finish up our section on implicit differentiation, where we work through finding the slopes of curves, or what we were going to just continue to call the slope of the tangent line to the curve for implicit function. So implicit function is something that looks like this equation over here, where we're not specifically solving the equation for y. It's not y equals, but they're sort of y's and x's mixed together. And these don't have to be functions, right? So we might not be able to solve them specifically for x or y. All right, so what we saw on Wednesday was we had this nice procedure for thinking about this. So we always wanted to think about y as a function of x. We know that we can't do that specifically, but it helps our notation here if we go through. And what I'm gonna do is I'm gonna rewrite my equation, but instead of y's, I'm gonna write out f of x. Okay, so our equation would look something like this. We'd have, it would be y squared, but instead of y, I'm gonna write in here, I'm gonna write f of x. And I'm gonna specifically replace that with an f of x. And so I get y squared plus, I'll leave that x, that color, plus x cubed equals x plus 1. Okay, and so step one, I'm going to make this substitution. You don't have to do this. If you can think about it with just a y in there and remember y is a function and use y primes, you can do that. So it's not uncommon. But I'm going to explicitly put this f of x in there just as a particular reminder that this thing is a function. And so when I take this derivative, I am going to have to use chain rule, right? So we are going to have to use different rules in here, like chain rule and product rule. So this is like a stark reminder that this is an inside function, and I have to use chain rule here. Okay, so when I go through, I'm going to take the derivative of this whole expression. So I'm going to get 2 times f of x. Right, this is going to be my chain rule part where I multiply by f prime of x. And then I'm going to add this to the derivative of x cubed, which is 3x squared. And this thing is going to be equal to 1 plus 0, right? So the derivative of x is 1, and then plus 1, that goes to 0. So when I look at this, my whole goal now becomes to find all of these f primes. Now, in this particular example, there's only one f prime, but what we're going to see later today is there could be more. So I'm going to solve this for f prime, and then I'm going to get an expression that gives me my derivative, right? So I'm going to have f prime equals something else. Okay, so what we'll do is the first thing, I'm going to just bring my 3x squared over to the other side. So I'm going to isolate all of my f primes on one side, and I'm going to take everything that doesn't have an f prime in it onto the other side. And so I get something that looks like this. And typically the last step is going to be to factor out all your f primes and then divide by whatever's left over. In this case, there's only one f prime, so I don't have to do any factoring. And so we get f prime of x is equal to 1 minus 3x squared divided by 2 f of x, right? So if we come down here, what I'm doing is I'm dividing both sides of this equation by 2 f of x. Okay, and then this is our final answer, right? So the derivative here, the slope, is given by this equation, and I sometimes think it's helpful then at the very last step to go back and replace that f of x with a y again. Okay, so what we have is we have this expression that's giving us our slope, and so if I want to find the value, what we can do is we come up here and we have our point, right? So this is really our x and our y values that we want to plug in. And we get 1 minus 3 times 0 squared all over 2 times 1, which is 1/2. Okay, so if we look at this, if we find the slope of the tangent line, we're going to come out with this. We'll take the derivative, just like we would. We have to think about y as a function, use our appropriate rules. and then solve for f prime and plug it in at the end. Okay, so depending on what you're being asked, this question, it asks us to find the slope of the tangent line, so we'd be done here. It's not uncommon to be asked to find the equation, in which case we just use point slope form, right? So we have the point that's up here, and then we have a slope down here. Okay, so I'll pause for a second and kick it back to you, see if there's any questions about this, what's going on here. These are good. Some feedback here. Thumbs up, thumbs down. Good, good, good. All right, I got half of you, the thumbs up. So, okay, so let's go ahead and let's just jump over to the book really quickly and see sort of where we're going from here. So, so in our book, what we were doing is we were thinking about, you know, these, I would say these are a little bit less complex implicit differentiation problems, because, you know, we might have a chain rule in there, but we haven't actually introduced any more complicated rules. So I think it's helpful to go through an example like this one right here. Okay, so if we look at this, what we're going to see is sometimes we can have other rules pop up, right? So you may have to use quotient rule, you may have to use chain rule, you may have to use product rule. And so when we look at this problem right here, one of the things that I want to point out is we have a product going on, right? So whenever we see y's, we're going to think of them as functions. So when I take the derivative of this piece right here, this y squared, that's going to be a chain rule. And then when I come over here, I have a 2x f of x, right? So this, when I take the derivative of this, I'm going to have to use product rule. Okay, so we'll walk through this one, but at each step of the way, you really have to be thinking of y is its own function. Okay, so there you have it's its own separate function. It could be anything. We don't know what it is. We don't have an explicit form. And so we will have to use the appropriate rules. Okay. So let's think through this one here together. All right. Okay, so I copied down the information. So here's our curve, x cubed plus y squared minus 2xy equals 2. And our point, we want to find the slope of the tangent line at -1, 1. Okay, so step 1, go ahead and replace all of your y's with f of x's. All right, so I'll go ahead and do this. And then what I want you all to do at home is to take a minute and try to take the derivative of this thing. Okay, so we talked through it a little bit. We're going to, right, so in this part right here that I'm writing in, this f of x squared, you're going to use chain rule. And then when you come up to this one over here, 2x f of x, you're going to use product rule. So let's all take a minute, right? So if you're here live right now, or if you're at home, so if you're watching on YouTube, this would be a good time. Pause it, try this out on your own, and then we'll come back together and see what we got. Okay, so 6 of you here, let's take a minute and see if we can think through this one. So we should have something that looks like what I wrote here, but down in this spot, we're gonna have something else. So does anybody have an idea? Does somebody want to kick over their idea? What goes in this spot right here? All right, so I'm leaving I left a big gap right here. So what goes right here? Product rule. Yeah. So Emily, you wanna tell us what it is?
Mine 2x times f prime of x plus 2f of x.
Mm-hmm. Okay, so if you have this, this is pretty good. Okay, so if you're checking in with yourself, right? So this looks pretty good to me, but what I wrote here is not quite right. So if you have exactly what I have written right here, you made a mistake, and this is what I call the most common mistake in calculus. I don't know if you recall what I've been, what I called the most common mistake in calculus, but yeah, algebra is a big one, right? So this goes along with algebra, but even more refined than that, inside of algebra, we forget to distribute our negatives, okay? So what we need is, with this subtraction sign right here, right? So we need to subtract the entire derivative. So with what I have written right here, I'm only subtracting the first term, right? So what I need is I need to put parentheses around this. And so when I simplify it, I need to make sure that if I get rid of these parentheses, that the negative goes to this plus sign as well. Okay, so I've been seeing this kind of error, right? So this right here, what we're seeing is forgetting to put that negative through a sum. So sometimes they pop up in unfamiliar places. So this is a super, super, super common error. So pointing it out now, right? If you made this error, make yourself a little note to keep your eye on this kind of thing as you're moving forward, right? So what we should have is parentheses here, and then that negative should distribute. So Emily, I don't know what you had, but you did a great job with the derivative. But I purposely made this mistake so I could make this point. But if you did make this mistake at home, then keep that in mind, right? So that's something that pops up a lot. All right, so we took the derivative. We're in pretty great shape. And now our job is to solve for f prime of x. Okay, so what we're going to do is we're going to go through, and we need to figure out where our f primes are. All right, so this is our f prime of x, and we need to solve for this thing, right? So we need to solve for this f prime of x. So what we're going to do is we're going to find all of our terms that don't have f primes in them, and we're going to put them onto the other side. Okay, so all my f prime terms are going to go over here. And then all of my non-f prime terms I'll put over here. And then all of my f prime terms will be over here on the left. Okay, so I'm going to start grouping things together. Okay, so I'll go ahead and I'll just do out all the steps here one at a time, right? So 3x squared plus 2f of x, f prime of x, minus 2x, f prime of x, minus 2, f of x equals 0. Okay, so I distributed that negative, and now I'm going to, so I'm going to go through here, and then I'm going to add, right? So I'm going to add my 2f of x over to the other side, and I'm going to subtract my 3x squared over to the other side. And what I'm left with is 2f of x, f prime of x, minus 2x f prime of x is equal to 2f of x minus 3x squared. Okay. Let's see if we can get some more space here. Okay, so now what I'm seeing, right, I still am looking for those f primes, and every term that's on the left-hand side should have an f prime of x in it. Okay, so some common questions from the past was like, well, how do I know if a term has an f prime in it? And so we're thinking about terms as pieces of a sum here. So if a bunch of things are being multiplied together, So all of these things, right, these are three things that are being multiplied together. I'm sort of clumping those into one term, right? So that term has an f prime of x in it, and then these three are all clumped together by multiplication. So that term has an f prime of x in it, but none of these do, right? So I'm trying to think about anything that's all multiplied together or divided in one expression. That's what I'm going to call a term. And so the terms are broken up by addition and subtraction as we go along. So I'm sort of moving these pieces around, and any term that has an f prime is on one side, any term that doesn't have an f prime is on the other side. And so what we're going to see very, very typically is, hey, now that everything has an f prime in it, I can factor that f prime out. Okay, so we're going to factor the f prime out of everything that's here, and what we'll be left with is 2f of x minus 2x, and then we'd have over here 2f of x minus 3x squared. Okay, and so that final step, what I can do is I can go through and then I'm going to divide, right? So I'm going to divide by this. I'm going to divide by this whole term on both sides, right? I'm going to divide by 2f of x minus 2x. And so the final result here is you get f prime of x is equal to 2f of x minus 3x squared divided by 2f of x minus 2x. Okay. Let's see if we can get this all on the screen. Okay. So the whole problem is here. We've gone through and we've found our derivative, but we're not done, right? So this isn't the end of it. What we need to do is we need to come back up and say, hey, right, what we were being asked to do is find the slope of the tangent line, so I need to use this point. So just at the end, right, if we come over here, our f prime of x is 2y minus 3x squared divided by 2y minus 2x. Okay, so we'd have this over here, and what I need to do is then take my x and y values and plug them in. So we should get f prime of x is equal to 2 times y, which is 1, minus 3 times negative 1 squared, all over 2 times 1, minus 2 times negative 1. And so what we should see is on top we get 2 minus 3, and that's negative 1. And on the bottom we get 2 minus negative 2, which is 4. And then we get negative 1/4 should be our answer. So I'm going to pause here and see if we have any questions about that. Did I make any errors? Emily's good. But everybody else, this is, I mean, there's a lot going on here. So any sort of steps along the way, sort of, you know, anywhere through here, or even over here, right, where we plugged it in. Everybody's pretty good with this? All right, so if we kick this back over, right, so we can verify, right, so if we want to go ahead and quickly verify, right, we'll pop up Desmos here, and so we can actually see what this looks like visually. And so with this was x cubed plus y squared minus 2xy equals 2, right? So that's the red curve that's going on here. Yeah, if anybody, right, if anybody has anything to do today, that's okay. What we're looking at here is we have this, right? We have this curve. You can think about this as a path somebody's traveling on or something on a map, and then at this point right here, this would be giving us how fast they're traveling, right? So they're traveling at this right -1/4. You know, the distance, this y distance is changing with respect to x at that point at -1/4, right? And so visually, what we see is the slope of the tangent line here is 1/4, and that this tangent line bumps right up against the curve, so we're in pretty good shape. Okay, so if we're ever unsure with a lot of these problems, right? Desmos again is a really great tool. We can do stuff just like this, right? So plotting the tangent line just with 3 lines, and it allows me to be very confident in my answer. It gives me sort of a visual representation of that. Okay, so let's jump back over to the book, and I want to think through this this problem, activity 2.7.2, together. Okay, we'll see if we can we'll think through this one. So I'll leave it up here for a minute, give you all a chance to read it, and then I'm not going to put us on breakout rooms. There are only 6 of us here today, so I think we can all sort of chat together. Can we do a quotient rule one? Yeah, where we see a quotient rule. So I can make one up. I'm gonna check, right? So we could have a quotient rule one. Yeah, so I can make one up. So Luke, the secret is you don't really ever have to do quotient rule, because anytime you have a denominator, you can multiply the whole expression through by that denominator and get rid of it. So we can do one. I can put one with quotient rule in there, but you're unlikely to see a whole lot of those, right? So just through some simplifications, you'll be able to get rid of those denominators. All right, so I think everybody had a chance to read this, but step 1, right? So why is it not possible to make this a function with explicit in x, right? So we have x equals y to the 5th minus 5y cubed plus 4y. And so what we want to do is figure out, why couldn't I solve this for y? Right? Why can't I write this as y equals something? That's totally impossible to do. So any ideas? There's too many y's. Yeah, so there's lots of y's, but that doesn't always preclude us from solving for them, right? So the answer here isn't like it's really hard. It certainly would be hard to do that, to solve that for y, but if we look at this thing visually, I think the visuals should point more to why this is impossible, right? You can't get a single expression, y equals this, looking at this graph here. In fact, we couldn't even do 2 or 3 expressions. Yeah, so there's multiple exponents. So Luke, you're still thinking about this one, right? So the algebraic representation, so you got a 5th and then a 3rd here. So what about graphically? Does anybody notice anything over here graphically? It's not a function, yeah, right? So this isn't a function, right? So it's not a function with respect to x. So if I draw a vertical line, like specifically at x equals 0, you can see that it hits the graph in 1, 2, 3, 4, 5 places, right? So what I would need is I would need 5 different functions. I would have to, you know, cobble together 5 different functions to describe this, right? Because there's 5 different outputs that go along with my input of 0, right? So for especially just right here, right? There's no way to write this as one term. We'd have to have multiples, right? So it's not a function. And so if we wanted to, we could break this up into a piecewise function where we take the derivative of a bunch of different parts separately, but we don't have to do that. Okay, so not necessary. All right, so what we're going to do is we can just think about this as an implicit function, and then we'll go through and take the derivative. All right, so you get x equals y to the 5th plus 5y cubed plus 4y. And so let's go ahead and take this derivative and sort of see what we get. So while you're all taking a moment to do that at home, I'm gonna make sure I copy this down correctly. And I'll bring up the board. Okay, and so once we have that derivative, it's asking us to find the slope of or find the equation of the tangent line at 0, 1. All right, so we've got our equation here. Okay. All right, so as we're taking this derivative, find the equation of the tangent line. So is anybody stuck on anything, or we're moving along pretty well? So what we should be seeing is something like this. X equals something to the 5th, 5 times something cubed plus 4 times something. And all of those things are functions. So all those y's are functions. Okay, so as you're going along, what we should be doing here, right, is you should have chain rule at each step of the way here. Okay, so I'm going to go ahead and take our derivative. So we get 1 is equal to 5 times f of x to the 4th times f prime of x minus 5 times, so this would be 15 times f of x squared times f prime of x plus 4 f prime of x. Okay. So far, so good? Excellent. Okay, so now, again, the next step, just like we saw before, we've got all of our f primes here, and we want to check, hey, all of our expressions that have f primes in them, are they on the same side? Do we need to rearrange anything? In this case, we don't, right? So everything over here, there's no f primes. Then all of my terms that are broken up by the pluses and minuses, each term here has an f prime in it. So we're good. We don't need to rearrange. I'm just going to go ahead and factor it out. So I get one single f prime of x times a bunch of stuff. 5 f of x to the 4th minus 15 f of x squared plus 4. Okay, so if you wanted to, right, at any point, once we take the derivative, you can replace these with y's if it's easier for you. And so if you do a lot of these, like I alluded to earlier, sometimes we just leave the y's in there the whole time. Remember that they're functions. Okay, so give ourselves a little bit more space here. So final step, I'm just going to go ahead and divide both sides. So I get 1 over, so let me try this. 5y to the 4th minus 15y squared plus 4 is equal to f prime of x. Was this okay for everybody? I didn't do it in 2 steps, just in 1 step when I brought it over. I divided by that whole term, and then I also simultaneously replaced my f of x's with y's. Good? Okay. All right, so then, right, so this would be our derivative, right? So I'm going to go ahead and let's zoom out and put this all on one piece here, right? So this is all the work we did to find our derivative, and now we don't want to forget about what the question was asking, which is, hey, we had this 0.01, and we need to figure out what the equation of the tangent line is at that particular point. So we have our point, we have our x value, our y value. Now we just need our slope, and so we will go ahead and find our slope, right? So our slope is going to be given by f prime, right? And we get 1 over, right? It's 5 times 1 to the 4th minus 15. So minus 15 times 1 squared plus 4. Okay, all of that's over that. And so what is this? This is 1 over 5 minus 15 plus 4, which is negative. Think about this. 5 minus 15 is negative 10, plus 4 is negative 6, so you got negative 1/6. Okay. So putting it all together, our equation should be y minus our y value, which is 1, is equal to our slope times x minus our x value, which is 0. Okay. And so what we're going to do is we're going to jump over to Desmos and we will verify this. So I'm not sure. It's possible that I made a mistake here, but I'm going to have you all double check me. Does this line up with what you got? You know, do we make any mistakes along the way? So while you're all thinking about this, I'm going to go ahead and type all of this into Desmos. It's good. Okay, so let's go ahead and jump back over to Desmos here. Okay, so here's our equation, right? So we get x equals y to the 5th minus 5y cubed plus 4y. That's our implicit curve here. And then our tangent line that we found is this y minus 1 is negative 1/6 x minus 0. And so if we zoom in here, right, we can see that that's that tangent line we're looking for, right? So the graph, the red line here goes up against the purple line, right? Just meets it at that 1 point at 0, 1. And that's what we should see. Now, so we only care locally, right? So way out here when it crosses the curve, right? We don't need that. We only care about really close to 0. Right? So this is what we want to be seeing. Okay. All right, and then if we go back, right? So here's the last question, right? So we did A, B, C, and it says, use your results from part B to determine all the points which the graph of this has a vertical tangent line. Okay, so we'll come back over here, and all right, if we zoom out, visually we should be able to figure out, hey, when does this have a vertical tangent line? And so any ideas for that? Where would we have a vertical tangent line? So on the same screen here, I'm gonna put our derivative, right? So we got this 1 over 5y to the fourth minus 15y squared. Any ideas? What we want to figure out? Hey, where does this thing have a vertical tangent line? So how might we do that? So let's try this. So since I'm sharing my screen, what you can all do is up at the top, you should be able to annotate. So there's that green bar. It says view options. You can annotate. So why don't you all try to do some annotation, right? So actually mark up this screen. Yeah, exactly right. Just like that. And then why don't you go ahead and tell me just visually where should the vertical tangent right? So vertical, yeah, vertical is going to go up and down like this. Yeah, so all these points, right? We see the different colors on the screen. So we should have these points right here, right? So over here, over here. So one of the cool things about Desmos, again, big fan of Desmos here. But if I click, right? So if I click on this, what we can do is we can see some points. Okay, so if you notice here, right? So the points that I have, right? So I can go ahead and move away from here. Things, but there's points right here. Like if I just click on my graph, Desmos sort of anticipates our points of interest, and so we can actually figure out, hey, what are the coordinates of those points? And so one of the interesting things here is, why would that happen, right? Why would we actually get these vertical tangent lines? And so looking at this expression, this is not going to exist. The slope of this is just not going to exist when the denominator is 0, right? So anytime, any y value that produces a 0 in this denominator should line up exactly with these points, right? So these y values, 1.644, 0.544, these should be the zeros of our denominator. And so one sort of clever thing that we could do is well, maybe we graph that. We could find our zeros, right? So these values right here are the zeros of our denominator. So positive and negative 1.644, positive and negative 0.544 are our values, okay? And then, those correspond to the y coordinates on our curves, right? So anytime we have a y coordinate at one of those points, we're going to have this vertical tangent line. And if you want to get the x coordinates, what you would do is you plug your y coordinate in here, and then you solve that for x, right? So that would give you, that's how you would find the different x coordinates. Okay, so So we're not going to walk through the algebra. You could, right? You could use algebra to solve this, right? So it is it's a quadratic equation in disguise. So we could use like quadratic formula, but we're not gonna spend time on that. Okay, so so we come down here. So annotate. Wonder how I. Here's a good question. So how do I clear all your drawings? All right. So I clear all drawings. Excellent. So okay. So we've got about 4 minutes left, but right. So we're going to skip this one, but we can have other things pop up. So some of these problems down here are ones that we might see. So we haven't done one with a trig function yet. So in activity 2.7.4 in our last few minutes here, I'll go ahead and walk through this one. Sine of y plus y equals x cubed plus x. So we can do this. Right, so if you want to, you could also bring this up in Desmos. Okay, so we're jumping back over. Okay, so sine of y plus y equals x cubed plus x. So we'll just sort of move through this one. So I'm going to go ahead and step one, I'm going to replace all my y's with f of x's just to remind myself that, hey, these things are functions, and I'm going to have to use things like chain rule as we go along. Step two, take the derivative. Okay, so when I'm taking the derivative here, I'm going to do derivative of sine as cosine, right? I'm going to leave my inside function alone, and then I have to multiply by the derivative of my inside function, right? So there's where I'm going to use chain rule. And then derivative of f is just f prime. And then nothing special on the right-hand side, we'll just use our normal derivative rules. Okay, so there's no f's over there. Now, what I need to do is I'm going to group all of my f primes together. Luckily, in this case, we're good. All of our f primes are on the left. So I'm just going to go ahead and factor this out. So we get cosine of, I'll just swap this out with a y since I'm done here, right? So cosine of y plus 1 is equal to 3x squared plus 1. And so our derivative that we're solving for here is 3x squared plus 1 divided by cosine of y plus 1. Okay. So sort of in turbo mode there. But so let me jump back over. So our directions were determine the equation of the tangent line. So I have my point is 0, 0. I need to go ahead and find my slope. So my slope here is going to be, I plug in 0 and 0. I'm plugging in 0 for x and y down here. So I'm going to get 3 times 0 squared plus 1 divided by cosine of 0 plus 1. And so the numerator, this is 1. What's cosine of 0? Cosine of 0 is 1. That's right. So you get 1/2. Okay, so what we should find here is when I find the equation of the tangent line, we would get y minus our y value, which is 0, is our slope, times x minus our x value, which is 0. And then so we could graph this and say, hey, y equals 1/2 x. Oh, did you want to say hi to everybody with your stickers? Yeah. We got a visitor at the end of class today, so Say hi, everybody. We say we just finished calculus. Yeah. Hi. Say, are you proud of your pigtails today?
Yeah.
Yeah. Wow. Everybody is excited to see you. They like your hair. Can you say, have a good weekend?
Have a good weekend.
All right. I'll come get you in just a minute, all right? Thank you. Okay, give Daddy one more minute, okay? And then you can come back. All right, so that's the bell. So I'm gonna have to go with her. But so this is pretty much the end, right? So this is the end of implicit differentiation, the end of chapter 2. So what we're gonna do next, so next Monday we'll start chapter 3. But don't forget that exam 2 is gonna open. So Sunday morning at 12 a.m., right? So at midnight on Sunday, exam 2 will open. It will close the following Sunday at midnight, so you'll have 8 full days. So somewhere in that 8 days, between Sunday and Sunday, you have to find a 2-hour block where you sit down and take the exam for that consecutive 2 hours. So once you click start the exam, that timer is going to go, and from that point, when you click into it, 2 hours later, the exam will close. Okay, so there's 30 questions in there, and they're all stuff from chapter 2. So from section 2.1 out through 2.7, homework 6 out to implicit differentiation on WebWorks. So if you want to go back and review those, they're all similar to the types of questions between homework 6 and implicit differentiation, which we did today. So any questions along the way, email me, and we can get everything sorted out. So have a great weekend. Spend some time with your families. Do something fun. We'll all meet back on Monday. So see you all later.